Hello and welcome to another LeetCode solution video. This is problem number 18 for sum. We are given an array nums of n integers, return an array of all the unique quadruplets, nums a, nums b, nums c, nums d, such that 0 is less than or equal to a, b, c, d, which is less than n, and a, b, c, and d are distinct. Nums a plus nums b plus nums c plus nums d equals the target. You may return the answer in any order. For example 1, nums is 1, 0, -1, 0, -2, and 2, and our target is 0. So our output for this would be -2, -1, 1, 2, -2, 0, 0, 2, and -1, 0, 0, 1. As each one of those quadruplets added up equals 0, which is our target. For example 2, nums is 2, 2, 2, 2, 2, and our target is 8, so our quadruplet would be 2, 2, 2, 2. Adding up that quadruplet would equal our target of 8. Let's go through an example. For this example, our input array is 1, 5, 2, -2, 0, 3, and -4, and our target is 0. This problem is very similar to another problem we've looked at previously, number 15, 3-sum. So we're going to follow a very similar pattern to that. The first thing we're going to do is sort our array. So now our input array is -4, -2, 0, 1, 2, 3, 5. And we're going to iterate through our input array and keep track of 4 points in our array. We're going to have our first index, our second index, then we're going to have our left point and our right point. And we're going to iterate through our input array, moving our left and right pointers towards each other, attempting to get our quadruplet sum equal to our target value. So for this first index, we're going to have -4 plus -2 plus 0 plus 5, and that equals -1, which is not equal to our target sum. And since our sum is less than our target value, we want to move our left pointer to the right to increase our total sum. So now our 4 points are -4, -2, 1, and 5, and adding those up, our sum is 0. So this is a valid 4-sum. So we'll add this to our output. So now we'll move our left and right pointers towards each other. And now our quadruplet is -4, -2, 2, and 3. Adding those up, our sum is -1, which is not equal to our target. And since our pointers are next to each other, we can now move our second index up and start the process over again. And now our quadruplet is -4, 0, 1, and 5. Adding that up, our sum is 2, which is not equal to our target. Since 2 is greater than 0, we'll move our right point to the left. Now our quadruplet is -4, 0, 1, and 3. Adding that up, it's 0, which is equal to our target. So we'll add this quadruplet to our output. And at this point, moving our left and right pointer towards each other will make them overlap, so we'll move on to our next index. Our new quadruplet is -4, 1, 2, 5. Adding that up, our sum is 4, and that is not equal to our target. Since it's greater, we'll move our right pointer in. Our sum is now 2, which is not equal to our target, and if we move our left and right pointers, they will overlap, so we will move our second index again. Our new sum is now 6, which is not equal to 0, and now that our second index and our left and right pointers are all right next to each other, we now want to move our first index point and start the process over again. Our new quadruplet sum is 4, not equal to our target, so we'll move our right pointer to the left. And now our quadruplet sum is 2, not equal to our target, so we'll move our right pointer to the left again. Now our quadruplet sum is 1, still not equal to our target, and our left and right pointers are about to overlap, so we will move our second index. Our quadruplet sum equals 6, not equal to our target, so we will move our right pointer in again. Our quadruplet sum is 4, still not equal to our target, and our left and right pointers are about to overlap, so we will move our second index again. Our quadruplet sum is 8, and our second index, left and right pointers are all about to overlap, so we will move our first index again. Our new sum is 8, and that is not equal to our target value. And at this point, we can see that all of our values are positive, and our target is 0, so none of these combinations will add up to our target value. So I'm just going to quickly show the rest of all of the quadruplets and their sums. So these are the remaining quadruplets and their sums. None of these are going to add up to our target because they're all positive numbers, obviously. But in our solution, we'll go through the rest of these and verify. And at this point, we'll output the 2 quadruplets we found while iterating through our input array. Let's jump into the code. The first thing we're going to want to do is sort our input nums array. Then we'll want to define our result output. Now we'll want to create our first loop, which will keep track of our first index point And this loop will only need to go to the length of our nums minus 3, since we'll have those 3 other points we're keeping track of in our quadruplet. And we can add some checks in our solution just to make sure our current index and our next index are not equal, just to remove any duplicate quadruplets. So if our current index value is equal to our next value in the array, we'll just skip the first one and move on to the second one, since they'll be the same quadruplets. Next, we'll want a loop to loop through our second index points in our array, and this will loop to the length of our nums minus 2, since we'll have our left and right points after this. And we can do the same duplicate check here to see if our current second index value is equal to our last second index value, and if it is, we'll just skip it to avoid duplicates. And now at this point, we'll want to define our left and right points. So our left will be equal to the next index in our array, so j plus 1, and our right point will be equal to the last index in our array. And the reason right is the length of our nums array minus 1 is because arrays start at 0, so we have to just subtract 1 off our length to get our index of our last value. And now we want to loop while our left point is less than our right point. And in this loop, we'll want to add up all 4 of our points to get our total and check it against our target value. So if our total value is less than our target value, we will increase our left point. If our total is greater than our target, then we'll decrease our right point. Otherwise, we'll have a valid quadruplet and we'll want to add that to our result. And if we have a valid quadruplet, we can also avoid further duplicates by increasing our left point until we reach a new value in our array. And we can decrease our right point until we reach a new value as well. And while doing this, we'll just want to make sure our left is still less than our right and they're not overlapping. And at this point, we will want to increase our left by 1 and decrease our right by 1 to get our next quadruplet. And now at this point, we can just return our result. That's it for the code, so let's run this. All cases passed, so let's submit. Our solution was accepted, so that's it for this problem. If you like this video and want to see more content like this, make sure to check out my channel. Thanks for watching.